Hey chemistry students, this is Mrs. Miller, and today we're going to be talking about how you're going to go through and you're going to be calculating pH problems. And today we're going to be working with two equations, one you can see up here and one down here. But first we have to talk a little bit about what pH is. In the previous section of notes, you guys learned a little bit about the pH scale, what is an acid, what is a base, and how do you tell if these things are acidic or basic. Well, in this video, we're going to talk a little bit more about what pH is and about that pH scale. So the pH scale is used to show the concentration of hydrogen ions in solution. So we're going to abbreviate that as H+. So why do we call it pH? Well, pH actually stands for something, and what it's going to stand for is the power of hydrogen. So we have it with a capital H to show that we're representing hydrogen, the element, and that's the most important part. So it's how powerful is the hydrogen within this solution, and that'll tell us more about its pH. Most of you guys probably know that the pH scale is going to range from 0 to 14. There are some things that can go over or under that, but most substances in our world are going to be between 0 and 14. When we look at the pH scale, when we have a pH of 7, we consider that to be neutral, meaning it's not acidic and it's not basic. Really, the few things that fall into this would be something like distilled water or the water that we use in labs, and that's right dead smack in the middle of our pH scale. When we look at a pH of 7, we call it neutral because the concentration of hydrogen ions and hydroxide ions are going to be equal. Here we have our pH scale. We have the acidic side, 0 to 6, neutral is 7, and then we have the alkaline or basic side, 8 to 14. This slide should be mainly a review for you guys as well. We know that if a solution is below 7, so here we're going to see 6 to 0, this is where we're going to see that it's acidic and it has lots of hydrogen ions. So this is often when we see like HCl, like hydrochloric acid, it has lots of hydrogen ions that are going to be in solution. When we see things that are above 7, we call those alkaline, or we also call those basic solutions, and that means that there is much more hydroxide ions, or OH ions, in that solution. So we have 8 all the way up to 14, which would be considered to be basic or alkaline. And then, as we previously talked about, we have that 7. We say pure water here, but of course we know that is distilled water, and that means it's neutral. So the number of hydroxide to hydrogen ions are going to be equal. One thing that may be new for you guys is that the pH scale is linked to a logarithmic function, or it's going to be increasing by powers of 10. So when we see the change in one pH unit, it corresponds to a 10-fold change in the concentrations of the hydroxide or hydronium. That's just another term for hydrogen ions. Hydroxide, of course, is OH. Oops, that should be a minus. And that's what we're going to see. So hydroxide is OH. Hydronium would just be the H+ or hydrogen ions. So when I look here, I can see that the stomach acid is in the 2, about 2.5, and then apple juice is at about 3.5. So because this is a logarithmic scale, we're going to notice that the stomach acid is going to be 10 times of a stronger acid than what we would see with apple juice. So every time you're moving by 1, you're really moving by 10. So if I were to compare apple juice to black coffee, it's 10 times 10. So apple juice is 100 times more acidic than coffee. The next thing that I want to get you guys used to is how we're going to go through and we're going to calculate pH. Well, we have a really simple mathematical equation. As I just told you guys, the pH scale is going to be a logarithmic scale, so we are going to be using the log function on our calculators. So to understand how we do this, we're going to look for pH, and pH is going to be equal to the negative log of the hydrogen ion concentration. So here we see this bracket. The brackets mean concentration. H+ is just the hydrogen ion that we see in an acid. So to calculate pH in our calculators, we're just going to do negative log of the concentration of hydrogen. pH, when we go and do this, is going to be estimated out to the tenths place, so 1 past the decimal. And we are also not going to put a unit with that, so no unit on pH. So that's different than what we always tell you. We always tell you to do no naked numbers, but here we're going to have that. So if we know what the concentration of hydronium is, what we do is we take the negative log of that and we plug that in our calculators, and in this case we end up with a pH of 4.7 going out to the tenths place and no unit. Here we have an example problem that's really similar to something that you guys are going to see on the pH problems practice or pH practice problems, whatever it's called. So it's similar, but it's not one from your sheet. So we have here a solution of hydrochloric acid, has a hydrogen concentration of 0.0005 m. M, remember, stands for molar. What is the pH, and is the solution an acid or a base? So what I'm going to do here is I'm going to color code this. The first part of the question we're going to do in blue. The second part of the question we're going to do in red. So we're going to start with this first part of the question. It says a solution of hydrochloric acid has the concentration that we have here. What is the pH? We know that pH is equal to the negative log of the hydrogen concentration. So what I'm going to do is I'm just going to plug those values in. pH is equal to negative log of 0.0005 molar. So that's the work we would expect you guys to see. And now I'm just going to plug that into my calculator, and I'll show you what that looks like on the next slide in just a moment. So pH in this case, when I put that in my calculator, I'm going to end up with 3.3 as my pH. So again, I'll show you what that looks like in a calculator in just a moment. The second part, though, is the solution an acid or a base. Well, we have something that is less than 7, so anything that is less than 7 is an acid. So that's how you would go through and do a problem where you are finding the pH from the concentration of hydrogen. I want to take a moment for you guys to see how I did this on my calculator. And what I did to start off with is I needed to do the negative log. So what I did is I pressed this button first, I press my log button second, and then it automatically is going to give me this part in my calculator, so the part of the parenthesis. I'm going to type in my 0.0005, so I typed that part in, and then I am just going to go and I'm going to hit this button third, which is going to close off my parentheses. If you didn't do that, you'd still get the same answer, but that's the order that I did it in. And when you end up, you get an answer, and again, you just want to go to the tenths place, so that's how you get 3.3. Your calculator might look a little bit different than mine. So I'm using a TI-83 Plus. You guys probably aren't using something like that, but those are the buttons you're going to need to do. So to get your negative, you have to find that symbol. To do your log, you need the log symbol, and then just to close your parenthesis. As we continue to go on your worksheet for the pH practice problems, you're also going to notice that there are questions where it's going to ask you to find the hydrogen concentration from the pH. So this is going to be the opposite of what we just did with that practice problem. So in order to find that concentration of hydrogen, we can calculate it using a different equation. So now, when we have this concentration, the opposite of doing a log is by putting something to the 10th or 10 to the power of something. So what we're going to do is we're going to take the hydrogen ion concentration is equal to 10 to the negative pH value. So when we look at this, when we get our answer, it's again going to be for the ion concentration. It's going to be expressed either as a decimal or in scientific notation, and then we want to know the units. And the units we're going to put on there is M, or that of course means molar to represent the concentration of that specific thing. So concentration is the same as M or molar. So 2 examples of what we might see is the decimal form and the scientific notation form. So if I'm looking at decimal form right here, I can see that I'm going to go 0.000035 molar. Scientific notation, that's just where I'm going to turn this into a value with one number ahead of that decimal place. So 3.5 times 10, and this should actually be times 10 to the -6th because I moved my decimal point in the right-hand direction. So again, this is going to be a practice problem that is similar to what you're going to see, but it's not exact. So this is where we want to find the hydrogen ion concentration from the pH. So we see that the pH of vinegar is 2.5. What is the concentration of hydrogen ions in the vinegar? So if we think back to what is the equation for this. So if I want to know what the hydrogen concentration is, that's going to be equal to 10 to the negative pH. So when I go ahead and I plug this in, we're looking for the concentration of hydrogen is equal to 10 to the negative. Our pH is 2.5. And when I go ahead and I calculate that, what I end up with from my calculator is H plus is equal to 0.0032 molar, or you could also do 3.2 times 10 to the negative third molar. So just like last time, I'm going to show you the buttons that I'm going to actually press on my calculator on the very next slide. So here we are again. My calculator again is a TI-83, so your buttons might be a little bit different than mine. But what you're going to see is we want to plug this in properly. So for me, what I wanted to do is I wanted to do the 10 to the x power. So what I have to do is any of my values that you guys can see in yellow here, I need to press the second value and then whatever the button is. So the order that I did this in is I pressed this button first, second, and then second, I chose log because then it gives me whatever that second power is. And here you can see what it did, 10 caret, and then it did my start of the parenthesis. Then what I did is I knew I needed to go to the negative of something. So I pressed this button, third, and then I plugged in 2.5. And then last, or fourth, I went ahead and I closed my parenthesis. So when I did that, you guys can see that I got 0.00316. I wanted to make sure that I only had 2 decimal places there. So what I did is the 6 causes the 1 to move up, and that's why we end up with 0.0032. The other way, again, molar, the other way I could do it is I need to move my decimal place. I'm moving it 3 and I'm moving it to the right. That's why it goes to the -3. So that's how you guys are going to go through and calculate pH problems. If you have any questions, let us know. Otherwise, have a great day.